Hi, good evening everyone. Myself P. Venkata Rao, faculty at ACE Engineering Academy, preparation strategy for calculus. Before going to talk about preparation strategy for calculus, first of all, let us briefly look at what are the topics and which topics have more weightage and more expected topics. Let me briefly talk about that, followed by let us enter into brief review regarding preparation strategy of calculus regarding engineering mathematics. What are the topics? Limits, continuity, differentiability. Limits, continuity, differentiability, maxima and minima, mean value theorems, definite integrals, improper integrals, multiple integrals, partial differentiation, Taylor series, Fourier series, vector calculus. These are the topics both for GATE as well as ESC. But for electronics and communication engineering students, they don't have Fourier series in the GATE syllabus, but it is in the ESC, both for GATE and ESC, it is there in the syllabus, except electronics. But for electronics and communication engineering, it is there in ESC. For computer science engineering students, we have only these topics for GATE: limits, continuity and differentiability, mean value theorems, maxima, minima, definite integrals. These are only the topics we have in the syllabus. So, but when you observe the last 30 years GATE solutions or GATE questions, the most important and expected topic is maxima and minima. Regarding maxima and minima, we have three different types also: local maxima and minima of single variable, global maxima and minima single variable, and local maxima and minima two variables. So, but complete all topics are important: local maxima minima, global maxima minima, as well as maxima minima two variables. But when you observe from last to 10 years, global maxima and minima, they are asking very frequently. So my sincere advice to everyone, never skip this global maxima, global minima. Apart from that, you should also have to prepare local maxima, local minima, single variable as well as two variables. The important textbooks: Thomas Calculus, 12th edition. You can download this book from internet, PDF format is available. Next book is called Stewart Calculus, Calculus 8th edition by James Stewart, which is also called Stewart Calculus. So now let us come to preparation strategy. So regarding preparation strategy, my sincere advice to all dear students, first of all, ACE Engineering Academy textbook, along with that last 30 years GATE solutions booklet. See, my sincere advice, once the class ACE Engineering Academy textbook you have thoroughly prepared, for example, throughout the engineering mathematics, one particular topic calculus is completed, then you need to practice last 30 years GATE questions from previous year GATE questions booklet. If it is completed, then you need to write frequently online based as well as offline based exams. So it will boost up your confidence, because when you are writing the GATE paper or when you will be writing the GATE exam, in the exam you will not feel shy, because frequently you are solving previous year GATE questions as well as frequently you write previous test series questions also. So therefore in the exam you don't feel shy, you feel comfortable, because real exam environment you have already felt when you are writing test series. So once it is already, this is the way you need to prepare to build up your confidence. And moreover, when you are preparing, for example, when you are preparing the calculus notes from the class or from ACE Academy textbook or from any other source, meanwhile you need to prepare the short notes as well. Short notes means in the short notes you should not write the definitions. Whatever you feel which are very important and key points of the complete calculus or complete engineering mathematics, key points are to be written in a separate short notes. So in this way, you need to prepare the short notes for all engineering mathematics topics like linear algebra, differential equations, calculus, probability, complex variables, numerical methods. So for the entire engineering mathematics, you have very limited pages regarding the short notes. In the short notes, whichever you feel it is somewhat typical, unable to remember, as well as that is very, very important for GATE exam point of view, as well as ESE exam point of view, please include them in the short notes. Please don't write definitions and unnecessary things in the short notes, because once you have prepared the short notes, first time only you have to thoroughly prepare. Second time onwards, you have to go through the short notes, what are the points are to be remembered, and any particular topic you felt it is somewhat typical and more revision is required, that particular topic you can go to the class notes and again practice that particular topic. This is the way you have to prepare the short notes, because when you have thoroughly written the short notes, it would be quite comfortable and it would be helpful before GATE exam. 2-3 days before GATE exam, referring all subjects, each and every subject throughout the notes, it will consume lot of time. So that's why 2-3 days before the GATE exam, when you refer the short notes of all topics of GATE syllabus, then overall you will get an idea regarding what are the topics and what to expect, what not to expect. And moreover, in the short notes, you need to write untapped areas also. Means any one particular topic which is not covered from last 20 to 30 years, please particularly remember the topic which we can expect either in the GATE or ESE. Moreover, one thing, ESE, we cannot say this is important, this is not important. ESE, width of the subject is vast, but depth of the subject is very, very limited. That means if for ESE you need to prepare more number of topics, but in the exam questions will be given directly from the standard textbook or simple questions will be given. But in the GATE, it will not be like that. Content is limited, but depth of the subject is very high, because it is an aptitude based test. Means they will test you your logical skills based on fundamentals and logic. You remember that GATE paper will not be too much critical or too much tough. The problems in the GATE will be given from basics and fundamentals, which are little bit tricky as well as logic based. Not only you are good at concepts, you must be able to solve the problems effectively. That means problem solving skills apart from concepts would be helpful to crack GATE. Whereas for ESE, you need to prepare more number of concepts and you must have command over the subject, but problems at basic level only. ESE 100 questions general studies paper are to be answered in 120 minutes. The approximate time should be around 60 to in between 60 and 70 seconds only. So ESE, some questions we can directly answer with the help of options, or some questions when you do the solution 50%, then you will get the clarity from the options what would be the right answer. It would be helpful so that we can easily solve it effectively within 1 minute. That is the style of ESE. Whereas in GATE also options would be helpful, but not up to that. So when you look at the questions, 2 options will be eliminated. From the remaining 2 options, you are unable to identify what would be the right option regarding GATE exam. For that, you need to do at least 50 to 60% of the solution. After that, just from the available remaining 2 options, we can easily identify the right option. But one thing, GATE 65 questions are to be answered in 180 minutes. So the approximate time for each question should be around 2.5 minutes. Of course, some problems will take 3 minutes time, some problems will take 5 minutes time, some problems will take half minute. The only thing is we need to manage the time. I said approximate, I said average time for each question to be attempted in the GATE should be around 2.5 minutes, not exactly 2.5 minutes. This is one of the important aspect, as well as effective utilization of virtual calculator effective utilization, because using our own personal scientific calculator we can do the calculations very fast and effectively, but it is not so in case of virtual calculator. If you don't have enough practice, then it is somewhat typical to do the problems using virtual calculator. So my sincere advice to each and every student who is preparing for GATE, please be careful regarding effective utilization of virtual calculator, because whatever the calculator available on your smartphones, the same type of calculator almost will appear on the computer screen. So by using that computer screen calculator, using virtual calculator, doing calculations will take some time. That's why I am suggesting you write test series questions. Frequently writing test series, because in the test series we have MSQs, multiple select questions, MCQs, multiple choice questions, as well as numerical answer type. So when you are doing the problems related to numerical answer type or MCQs or MSQs, you may come across a problem is related to calculation. So for that, virtual calculator is required. If you are writing online based exam, then you will get a command regarding how to effectively utilize that calculator, and it would be helpful when you are writing GATE exam. So that's why frequently my sincere suggestion, write as many tests as possible so that you will get a command regarding how to use that virtual calculator effectively. That also matters up to some extent to decide your GATE rank. So please be careful. So fast and accuracy is also important. Generally, fast and accuracy means if you write slowly, step by step, it will consume lot of your valuable time. So whatever the key points, when you look at the question, what is given, what to solve and what to find, write important and effective points only, because the space would be very limited, so that you have to write your solution effectively, so that you can manage the time. While you are doing the problem very fastly, then you may commit some mistakes. That depends on practice. By doing the problems very fastly without committing any mistakes, that skill will be improved by practicing the questions as many times as possible. As many times as possible means not same questions. You may solve the questions from previous year GATE test series by solving as many different quality questions as possible, so that automatically fast and accuracy skill will be improved. It is purely dependent on your practice only. Focus on untapped areas. Never neglect untapped areas, because nowadays from last 5-6 years they are giving the questions from untapped areas, especially in the GATE. But for ESC, we should not think this is expected, this is not expected. Everything you have to prepare thoroughly for ESC. Then only you can score good marks. But it is not so in GATE. In GATE, sometimes some of the particular topics are there which we can frequently expect in the GATE, but very rarely they will cover the questions from untapped areas as well. Moreover, subject allocation in a day. So throughout the day, if you completely prepare the calculus, after 4-5 hours, definitely you get discharged. The mind will be blank and it doesn't work properly. So that's why if you are BTech engineering completed student, if you have 8 hours in a day for preparation, then 4 hours one particular subject, 4 hours another particular subject you can allocate. So meanwhile, after 1 week or after 10 days, simultaneously you must be able to complete these 2 subjects, because after some time switch over to other subject, it would be helpful, and at the same time your mind is refreshing. So subject allocation is very, very important. And college goers, they feel somewhat typical regarding subject allocation in a day. College goers, hardly you find 3 hours or 4 hours in a day, then 1.5 hour one particular subject and 1.5 hour other particular subject, or take one particular subject and focus on that one particular subject only in this 3 to 4 hours. That's why college goers have to start the preparation very early, because you have very limited time. So that, and you have very limited time, because once you go to the college you have some other works, so you have very less time for your preparation. If you can start the preparation very early, so that you are able to manage the time in order to complete the whole GATE syllabus or ESC syllabus. So this is the way you need to prepare. So before going to talk about that, now calculus, one particular topic I want to cover, because in this session some theory as well as problems. In this session, let me complete the theory. In the next session, that is on 12th May 2022, we will do problems session. So that's why first let me complete, because if I touch each and every topic of calculus, then this 1 hour session will not be sufficient, and you will also will not get confident or command over any subject. So that's why in this 1 hour session, let me complete the theory regarding maxima minima. In the next session, that will be on 12th May 2022, we will be doing problems on that maxima minima regarding the concept that we have learned. So regarding, before going to talk about maxima and minima, first let us briefly review what do you mean by stationary point, what do you mean by critical point, what is the difference between stationary point and critical point, why we are discussing about stationary point and critical point. First of all, remember, maxima and minima occur at critical points or stationary points. So that's why before going to talk about maxima or minima, first let us know what is stationary point and what is critical point. What do you mean by stationary point? Stationary point means the point at which, stationary point means the point at which f dash x is 0, the point at which slope is 0, the point at which the tangent drawn to the curve is parallel to x-axis is called stationary point. Stationary point means what? The point at which f dash x is 0, means slope 0, means the point at which the tangent drawn to the curve is parallel to x-axis. Because maxima and minima may occur at the stationary points, means at the points where the tangent drawn to the curve is parallel to x-axis, there may exist either a maximum value or a minimum value. So what do you mean by critical point? Stationary point means the point at which f dash x is 0. Critical point means what? The point at which either f dash x is 0 or f dash x is infinity, means f dash x is undefined, means f of x is not differentiable. That is called critical point. Critical point means what? The point at which either f dash x is 0 or f dash x infinity. The point at which either f dash x is 0 or f dash x infinity, means f dash x undefined, means f of x is not differentiable, is called critical point. And what do you mean by inflection point? Inflection point means what? Please be careful what I am talking about. Inflection point. Remember, inflection point means the point at which graph of the function, the point at which graph of the function has a tangent line, and at the same point curve changes its shape from concave up to concave down or vice versa. Concave up means what? Very simple. Concave up means bowl holding water, that is concave up shape. Concave down means bowl spilling water, that is concave down. So the point at which graph of the function has a tangent line and at the same point concavity changes, means curve changes its shape from concave up to concave down or vice versa, that is called inflection point. For example, look at this. You look at the curve. This is the point. This is the point. At this point, concavity changes, means curve shape will change from concave down. This is concave down shape, this is concave up shape. The point at which graph of the function has a, this is graph of the function that has a tangent line, and at the same point concavity changes, means curve changes its shape from concave down to concave up or vice versa, that is called inflection point. And moreover, you look at this another diagram. You observe this. This is a point. This is a point. This is a point. The point at which graph of the function has a tangent line, and at the same point curve changes its shape from concave up to concave down. This is concave up shape. This is concave up shape and this is concave down. So at this point only concavity changes. At this point only curve changes its shape from concave up to concave down. So this is called inflection point. Remember, inflection point means point of no maxima, no minima. At inflection point, graph of the function has neither a maximum nor a minimum. Because look at this curve. This is the, what is the smallest height of the curve from x-axis? Look, this is the smallest height of the curve from x-axis. This is the smallest height of the curve from x-axis. This is minimum value. This is the largest height of the curve from x-axis. This is maximum value. But this is inflection point. At this point we have neither a maximum nor a minimum. So this is not an inflection point. This is an inflection point, but this is the point at which no maxima, no minima. So therefore, everyone has to remember that at inflection point, graph of the function has neither a maximum nor a minimum. Remember that. Mathematically, how would you define inflection point? Let me check that one also. Mathematically, this is the way we can define inflection point. The point at which second derivative is 0. The point at which second derivative 0 and the third derivative not equal to 0. The point at which second derivative 0 and third derivative not equal to 0 is called inflection point. Or the point at which second derivative is undefined. The point at which second derivative is undefined. That is also called inflection point. If you get f double dash x is undefined, means f double dash x is infinity, then it is an inflection point. So remember, at inflection point there is no maximum and no minimum. Now look at this curve. Observe this. This is a stationary point. This is a stationary point as well as critical point. It is a stationary point, critical point, and this is minimum. Stationary point means what? The point at which f dash x is 0. F dash x is 0 at any one particular point meant for at that particular point the tangent drawn to the curve is parallel to x-axis. F dash x is 0 means slope 0. X-axis slope 0, therefore this tangent is parallel to x-axis. Therefore, stationary point means the point at which f dash x is 0. Critical point means the point at which f dash x is 0 or f dash x infinity, that is called critical point. So this is a stationary point, this is a critical point, this is the minimum height of the curve from x-axis. So finally what I wish to say is maxima and minima occur at stationary point or critical point. Now you observe, this is a critical point. Observe this carefully. This is a critical point. Critical point means what? The point at which either f dash x is 0 or f dash x infinity, means f dash x undefined, means f of x is not differentiable, that is called f dash x undefined or critical point. Look at this curve. As we all know, at sharp edges, at sharp corners of the curve, at corner points of the curve, function will not be differentiable. Will not be differentiable at all corner points of the function. So this is a sharp edge, sharp corner. So therefore, at this point, function will not be differentiable. means f dash x is undefined. Therefore, f of x is not differentiable. So the point at which f dash x undefined or f dash x infinity, that is a critical point. So, but it is the smallest height of the curve from x-axis. At a critical point, minimum exists. Now you observe here slope 0, x-axis slope 0. Therefore, any other line which is parallel to x-axis whose slope should also be 0. This is parallel to x-axis, therefore slope of this line is also 0. What is this? Tangent line. It is parallel to x-axis. Therefore, slope of this tangent line will be 0. So, f dash x is 0. The point at which f dash x is 0 is a stationary point. The point at which f dash x is 0 or f dash x infinity critical point, and this is the maximum. This is not minimum, this is the maximum height of the curve from x-axis. This is the maximum height of the curve from x-axis, it is not minimum. So remember, in all the cases right from the beginning, we are talking about stationary point as well as critical point, and maxima and minima occurring at all these stationary points are critical points. Now you observe one more similar. This is a corner point. At all corner points, f dash x infinity means undefined. So it is a critical point. It is a critical point and it is the maximum. It is the maximum, largest height of the curve from x-axis. So this is the maximum. So at all stationary points, see maxima and minima occur at stationary points are critical points. But converse need not be true. I will also explain that. Once again remember, maxima and minima occur at critical points or stationary points, but converse need not be true. Means what? At each stationary point, it is not compulsory that function having either a maximum or a minima. One function having either a maximum or a minimum, definitely one function having maxima or minima at one particular point, definitely that particular point is a, I am talking about local maxima, local minima, definitely that particular point is a stationary point or critical point. But converse need not be true. Means at each critical point, function need not have either a maxima or minima. You'll see that example as well. Observe this and look at that. So the point at which, now you observe, this is the point at which graph of the function has a tangent line. Now you observe the point at which graph of the function has a tangent line, and at the same point curve changes its shape from concave down to concave up or vice versa. That point is called inflection point. And moreover, this is a stationary point. How do you say it is a stationary point? Please be careful. It is a stationary point, it is a critical point, and it is an inflection point as well. Why it is a stationary point? This tangent is parallel to x-axis. Therefore, slope of this tangent equal to slope of x-axis. What is x-axis slope? 0. Therefore, this tangent parallel to x-axis, therefore slope of the tangent is also 0. Tangent slope 0 is denoted by f dash x 0. Tangent slope 0 at x equal to a is denoted by f dash of a equal to 0. So the point at which f dash x is 0 is called stationary point. The point at which f dash x is 0 or f dash x infinity is called a critical point. So basically it is a stationary point and critical point as well. And why it is an inflection point? The point at which graph has a tangent and at the same point curve changes its shape from concave down to concave up or vice versa. So it is an inflection point. And moreover, at all inflection points, we have neither a maximum nor a minimum, because this is the smallest height of the curve, this is the largest height of the curve. So this is maximum, this is minimum, but this is point of inflection, which is neither a maximum nor a minimum. So therefore, as I told you, maxima and minima occur at critical points, but converse need not be true. Means at each critical point or stationary point, maxima or minima, function need not have maxima or minima. This is a critical point, but having neither a maximum nor a minimum. And similarly, look at this. This is a tangent, this is the curve, this is the curve, you observe. So first of all, you observe this is the y-axis, this is y-axis, this is a tangent drawn to the curve at this particular point. Let this particular point be something, a or whatever it is, x equal to a, something. So therefore, this tangent parallel to y-axis. Therefore, slope of this tangent equal to slope of y-axis. What is y-axis slope? Undefined. Undefined means dy by dx is infinity or does not exist. This is parallel to y-axis. Therefore, the slope of this line is also undefined. Means f dash x is infinity. So therefore, the point at which f dash x undefined, f dash x infinity is called a critical point. So therefore, it is basically a critical point, and at the same time, why it has become an inflection point? The point at which graph of the function, this is the point at which graph of the function having a tangent, and at the same point concavity changes, means curve changes its shape from concave up to concave down or vice versa. Therefore, it is an inflection point. As we all know, at all inflection points, there is neither a maximum nor a minimum. So therefore, we have already seen one function having either a maxima or a minima, definitely it should be at stationary point or critical point. But at all, converse need not be true. At all critical points, function having critical or stationary point, function need not have either a maxima or minima. Now let us see what is the definition of local maximum as well as local minimum. So why Sir continuously talking about local maxima, local minima? Because we have local maximum and minimum as well as global maxima and minima. Global maxima and minima also called absolute maxima and minima. Local maxima and minima also called relative maxima and minima. Both for GATE and ESC, local maxima and minima as well as absolute maxima and minima, also called global maxima and minima, are more important and expected topic. Please be careful. ESC students, in the GATE okay, in the GATE whatever the time will be given, 65 questions are to be answered in 180 minutes. That would be quite comfortable. Almost we can effectively manage the time. But for ESC, the only thing is some problems you need to solve with the help of options. Some problems you have to increase your calculation speed. Then only you are able to manage the time. Not for every problem. Some problems by increasing the calculation speed only you are able to. Means by solving as many questions as possible within the stipulated time, that matters. But in the GATE, the only thing is time would be sufficient, but the only thing is you have to think logically and apply your abilities, apply your skills to solve one particular problem effectively. That matters. Suppose that logic, if it is not strike off, then it is somewhat typical. And if the logic, if you are unable to grasp to do one particular problem, then you are unable to solve that particular problem. In GATE also, in MSQs also, when you look at the options, sometimes it seems all options are correct. But until and unless you have command, means complete conceptual knowledge if you don't have, it is somewhat typical to select the right options from MSQs. Because in MSQs, they will give the questions in such a way that it looks like all options are correct. But if you have command over the subject, sometimes by looking at the options, we can easily recognize two options would be eliminated or one option will be eliminated. Elimination techniques and some other procedures we need to adopt. Everything, every skill must be improved just because of practice, practice, practice. The one and only one thing, logical skills will be improved. Practicing previous year gate questions, writing test series, practicing as many different quality questions as possible by collecting the questions from different sources. That is very important. Let us see the definition of maximum. I mean local maximum this is. What do you mean by local maximum? Local maximum, talking about a definition, please be careful. Suppose I want to consider neighborhood of A. Neighborhood of A means what? This is A. Neighborhood of A means some surrounding area of A. Let that some surrounding area of A is A minus delta and A plus delta. What is delta? Delta is very small, very nearer to 0 but not 0. That is delta. So this is the neighborhood of A. What is the height of the curve? This is f of A. This height, this is f of A. F of x at x equal to A is f of A. Suppose f of x value at each and every point in the neighborhood of A. Please be careful what I am talking about. Suppose f of x value is less than or equal to f of A. F of A means what? Height of the curve from x-axis at A. F of A means curve height from x-axis at A is f of A. This is f of A. F of x value at each and every point in the neighborhood of A is less than or equal to f of A, then f of x will have a local maximum at the point x equal to A. So this is f of x and this is f of x value in the neighborhood of A. These are the f of x values in the neighborhood of A. F of x value in the neighborhood of A means heights of the curves from x-axis at different points in the neighborhood of A. So this is f of x value in the neighborhood of A. These are heights of f of x values means heights of the curves from x-axis in the neighborhood of A. Heights of the curves from x-axis in the neighborhood of A. So f of x, now you observe among all, when you look at the neighborhood region of A minus delta and A plus delta, among all, white color curve is the largest height from x-axis. White color curve is the largest height from x-axis as compared to all other yellow curves in its neighborhood. That means f of x values, these are yellow color lines are f of x values in the neighborhoods of A. In the neighborhood of A. So f of x value less than or equal to f of A. F of x value is equal to f of A or less than f of A throughout the neighborhood of A, that means in the interval A minus delta and A plus delta, then f of x has a local maximum. It is a local maximum. So what is global maximum and minimum? You'll see. First let me complete this. So what do you mean by local minimum? The same story is applicable local minimum as well. Local minimum means what? F of x value greater than or equal to f of A throughout the region A minus delta and A plus delta. So this is the neighborhood of A. Neighborhood of A means A minus delta and A plus delta. This is A minus delta. This is A plus delta. So f of x value at each and every point. F of x value at each, this is A minus delta, this is A plus delta. F of x value, this is f of x value at this particular point. This is f of x value at this particular point, f of x value at this particular point, f of x value at this particular point. Suppose f of x value is greater or equal to f of a for all x values means except a, because f of a we found separately. F of x value for all x values in the neighborhood of a minus delta and a plus delta except at a, f of x value is greater than or equal to, this is f of a, this white color line is f of a. This white color line is f of a. So f of x value is greater than or equal to f of a for all x values in its neighborhood except at a. Then f of x has a local minimum. This is the definition of local minima as well as local maximum definition we have already seen. Now look at this. We are talking about global maximum and global minimum also. Global maximum and global minimum, please be careful, as well as local maxima and minima also we think of. And moreover, you observe this. From the diagram, just observe the largest height of the curve from x-axis. Remember, in the GATE exam or in ESC exam, they don't mention. Sometimes, very rarely they mention. Most of the times, either in the GATE or ESC, they do not mention it. The problem is related to global maxima, global minima, or local maxima, local minima. You only have to decide whether your problem belongs to either a global maximum or a global minimum or local maximum, local minimum. Very, very simple to say. Suppose f of x is defined in certain interval. Suppose f of x is defined in certain interval and you are asked to find maxima and minima, then you need to find global maxima and global minima, also called absolute maxima and minima. Suppose you are asked to find maxima and minima, but interval not given in the statement of the problem, then you people have to find local maxima and local minima. Look at the diagram. The largest height of the curve from x-axis is global maximum. This is the largest height of the curve from x-axis. Therefore, this is the global maximum. Of course, this is also the largest height of the curve from x-axis. This is also the global maxima, but I wish to write like this. Here the tangent drawn to the curve is parallel to x-axis. So here if x-axis, two lines are parallel, their slopes are same. This tangent parallel to x-axis, therefore slope of this tangent equal to slope of x-axis, x-axis slope 0, therefore this tangent slope 0, tangent slope 0 means f dash x is 0. Look at this, this is also parallel to x-axis. So this tangent slope also 0, but I want to modify this. Suppose this tangent slope at which point? We want this tangent slope at x2, 0. Here tangent slope at x4 means f dash of x4, 0. But I want to modify this diagram just for the, right now only I am just modifying. If it is like this, I want to give it as a sharp corner. Sharp corners means like this. These are the sharp edges. At all sharp edges, function will not be differentiable. So I want to make it as a sharp edge. So actually different curve is given. I am right now modifying. This is a sharp corner. At a sharp corners, f of x is not differentiable, means f dash x is infinity, means f dash x is undefined. F dash x is infinity means f dash x is undefined, means f dash x is infinity. So, but this is also the largest height of the curve from x-axis. Therefore, this is also the global maximum. So, here this is the global maximum at which f dash x is 0. This is also the global maximum at which f dash x is undefined, means f dash x is infinity, means f of x is not differentiable. The largest height of the curve from x-axis is a global maximum. Smallest height of the curve from x-axis is a global minimum. Which is the smallest height of the curve from x-axis? This is the smallest height of the curve from x-axis. This is the smallest height of the curve from x-axis. Therefore, it is global minimum, also called absolute minimum. And now you look at this curve. This is the largest height of the curve from x-axis, global maximum. What is this? This is not largest height, but it is a larger height of the curve from x-axis. Largest is global maximum. Larger height from x-axis will be local maximum. This is the larger height from x-axis, so this is a local maximum. And even this is also larger height of the curve. This is the largest height, this is only larger height. Larger height of the curve from x-axis is local maximum. This is also local maximum. But at this point, this tangent is parallel to x-axis. Therefore, slope of this tangent is 0 because it is parallel to x-axis. So, slope at x0 is 0. This tangent also parallel to x-axis. So, this tangent slope equal to x-axis slope. So, x-axis slope 0. Therefore, this tangent slope should also be 0. Means f dash x is 0. F dash x at x6 is 0. Now you observe, this is the smallest height of the curve from x-axis, which is global minima. Is it the smallest height of the curve? These you observe, these two. This is not smallest height from x-axis. This is not smallest height from x-axis. That is smallest height from x-axis, which is global minimum, but it is these two are not this. This. Now you observe this and this both are smaller heights from x-axis. Smaller heights from x-axis is local minimum. Smallest height is global minimum. This is also smaller height from x-axis. This is also local minimum. This is also smaller height from x-axis. This is also local minimum. Here f dash of x0 0, f dash of x1 0 because tangents are parallel to x-axis, f dash of x3 0, f dash of x5 0, f dash of x6 0. So this is the story regarding global maxima, global minima. So several times in the GATE exam we were given problems related to global maxima, global minima, including 2022 electronics and instrumentation. So that's why let us briefly review the procedure of calculating global maxima, global minima, followed by procedure of calculation of local maxima and local minima, because in the next session we will be doing problems on global maxima, global minima, local maxima, local minima, as well as maxima, minima, local maxima, minima, two variables. So that's why you will have some clarity. That's why let us. So what is the procedure of calculating global maxima, global minima? Procedure of calculating global maxima, global minima is, first of all, you have to find interior critical points. Interior critical points means in the exam you will be asked to find maxima and minima. How would you understand? This problem belongs to global maxima, global minima. he will be given certain interval, then immediately recognize this belongs to global maxima, global minima. So I am saying here, find the interior critical points, means how many critical points of the function will lie inside the given interval. Find the interior critical points. Actually, by finding the critical point means the point at which f dash x is 0 or f dash x infinity. You will get some critical points. Among all critical points, how many critical points lying inside the given interval you need to recognize and consider only those critical points. Rest of all critical points should be omitted. Next, suppose this data, it will be assumed. Actually, this procedure is assumed. We assume that f of x is a continuous function and are defined in an interval AB. Next, you need to find the critical points. Assume the critical points as, just for convenience only I am saying, assume critical points as, for theoretical wise only I am saying, x0, x1, x2, etc. And what are endpoints of the curve? Endpoints. What are endpoints of the curve? No need to write. Remember, endpoints of the curve are A, B and something. A, B. These are the endpoints of the curve. First of all, you have to find the critical points and endpoints. Now you need to find local maxima and minima. At all these local maxima and minima will be found at critical points only. Find local maximum. How to find local maximum and minimum? I will let you know. Find local maximum and minimum at all critical points. So once you get the local maxima and minima at all critical points, this is the way to write global maximum. Global maximum means what? Global maximum equal to largest value of f of a. What is a? A means one endpoint of the given interval, means one endpoint of the curve. B means another endpoint of the given interval, means another endpoint of the curve. Largest value of f of a, f of b. F of a means what? Height of the curve from x-axis at x equal to a. That is f of a. F of b means curve height from x-axis at b. And all local maximum values. How to find local maxima and minima, I will let you know right now. And all local maximum values means at which points, at which critical point does the given function having a local maximum, first you need to observe and then find local maximum value at that point. For example, f of x has a local maximum at x0, find f of x0. F of x0 will be the value of local maximum. So local maximum value means f of x0. So among all these, f of x at one endpoint of the curve, f of x at another endpoint of the curve, and find all local maxima values. Means suppose f of x having local maximum at x0, then f of x0 will be the local maximum value. So find all these. Among all these, largest is global maximum, smallest is global minimum. So f of a value you will get something, f of b value will get something, and all local maximum values you will get something. Among all these, biggest is global maximum, smallest will be global minimum. So what is global minimum? Global minimum means smallest value of smallest value of f of a, f of b, and all local minimum values. All local minimum values. Remember once again, what is the procedure of finding global maxima, global minima? Very simple. Point number one, find critical points. Means first you have to find f dash x. That f dash x becomes 0 or infinity at how many points you have to check. Those are the critical points. Among these critical points, how many critical points lying inside the given interval you consider? Any critical point lying outside the given interval, skip that. And these are the critical points. At these critical points, find local maxima, local minima. And then global maxima is f of a, f of b, and all local maximum values. Global minima is smallest value of f of a, f of b, all local minimum values. So once we do the problems, we'll get a clarity. We'll be doing in the next session regarding problems of global maxima, global minima, as well as local maxima and minima. So, what is the procedure of local maxima and minima, also called relative maxima and minima? Before going to talk about local maxima and local minima, you should have a minimum basic knowledge about when is the function said to be increasing function. I am just not giving the definition. Condition for increasing, very simple. Suppose f dash x is greater than 0. Suppose f dash x greater than 0 in certain interval. Throughout that interval, f of x is increasing function. If f dash x greater than 0 on certain interval, throughout that interval, f of x is increasing function. F of x is increasing function. Remember, increasing nature or decreasing nature can be decided just by looking the curve from left to right only. When I view the curve from left to right, it is rising. When I view the curve from right to left, it is falling down. But you people have to remember that increasing nature or decreasing nature can be decided just by looking the curve from left to right only. From left to right, it is rising. So, it is increasing function in the interval AB. Remember, f dash x greater than 0 on certain interval, it is rising in that interval, means increasing function in that interval. Suppose f dash x less than 0 in certain interval, throughout that interval, the function is a decreasing function. Means when you draw the curve, it is decreasing. It is falling down. When you draw the curve from left to right, it is simply a falling curve, a falling down. So, f dash x less than 0 in certain interval, throughout that interval it is falling down, and that is the condition for decreasing. And similarly, how do you say it is a concavity? Remember, first derivative will tell you about the curve is rising or falling. Means using slopes we can decide it is if slope positive. If slope positive means f dash x greater than 0, means dy by dx greater than 0, it is a rising curve. Slope negative, dy by dx negative, f dash x negative, curve is falling down, means decreasing function. So first derivative will let you know increasing nature or decreasing nature of a curve or function. What about the second derivative? Second derivative will let you know the curvature of a curve. Means at what rate slope changes. I mean curvature of a curve. I mean the curve becoming a concave up or concave down. Its nature, curvature of a curve means it is just like concave up shape or concave down shape, can be decided using second derivative. So some people have already got an idea or a doubt, sir, what third derivative will represent? Third derivative will represent jerk. Third derivative will represent jerk, means at what rate curvature will changes. So a vehicle which is moving suddenly giving jerks. So third derivative giving jerking. So what is second derivative? If f double dash x greater than 0 in certain interval, then in that interval the curve is a concave up shape. In 2022 GATE electrical engineering, we were given one 2 marks problem and we were asked whether the function is increasing or decreasing. Simply you need to find f dash x. By finding f dash x nature, we can decide whether it is increasing or decreasing. But your doubt is, already in production engineering 2015, one problem was given 2 marks. There we were asked the problem is related to concave up or concave down. That can be decided using second derivative. Means if f double dash x greater than 0 on certain interval, then in that interval the curve will look like concave up, means bowl holding water. So in this interval it is looking like concave up. F double dash x greater than 0 means. Similarly, f double dash x less than 0, if f double dash x less than 0 in certain interval, it lets you know it is concave down. F double dash x less than 0 in certain interval, in this interval it is concave down. This. Now let us see briefly local maxima as well as minima. I mean procedure. You remember what is the global maxima, global minima? The only difference between local maxima minima as well as global maxima minima is regarding global maxima minima, function must be defined on certain interval, whereas a local maxima and minima, interval should not be given. Only function will be given, then you have to find local maxima minima. For local maxima and minima as well as global maxima minima, first you need to find critical points only. Find the critical points of the function. For your convenience, assume the critical points as x0, x1. Assume the critical points as x0, x1, x2, x3, x4, so on. At each and every critical point, find f double dash x. At each and every critical point, find f double dash x. Find f double dash x at the critical points x0, x1, x2, so on. Suppose f double dash x less than 0. If f double dash of x less than 0 at any critical point, if f double dash x less than 0 at any critical point, then the function will have a local maximum at that critical point x0. Then f of x has a local maximum at that critical point x0. suppose f double dash of x at any critical point x1, at any point let that point be x1, I mean let that critical point be x1. If f double dash of x at any critical point greater than 0, then f of x has a local minimum at that particular critical point, has a local minimum at that particular critical point. So already you people got an idea, I mean doubt, f double dash x less than 0 at any critical point maxima, greater than 0 minima. What about f double dash x is 0? If f double dash x at any critical point is 0, then the given function may or may not have either a maxima or minima. If it has a maximum value, how to find that particular maxima or minima? Then f of x may or may not have, may or may not have either a maximum or minimum. Suppose it has a maximum or minimum, how to find that? So whenever f double dash x is 0 at any particular point, then only you can use nth derivative test, to calculate local maxima or minima or no local maxima or minima. That is this, suppose f dash x is 0, f double dash x is 0, f double dash x is f dash x is 0, f double dash x is 0, f triple dash x 0. And n minus 1th derivative of x is also 0, but nth derivative of x at any one particular point is not equal to 0. So first derivative, second derivative, n minus 1th derivative 0, but nth derivative at one particular point not 0. Now remember this. If n is even, n is even means n, 2, 3, 4, 5, so on, and f power n of x less than 0, or f power n of x at x naught less than 0. If you want, you can take the point x naught, no issues, means n at one particular point, n is even number as well as nth derivative of f of x at x naught less than 0, then f of x has a local maximum, at x equal to x naught. N is even. What is the first even number? 2. Take n equal to 2, means f double dash of x naught less than 0, f of x has a local maximum. Suppose f double dash x is 0, n value 3, 3 minus 1, 2. F double dash x is 0, what is the next even number? Next even number is 4. Take n equal to 4, f power 4 of x naught less than 0, means f dash x is 0, f double dash x is 0, f triple dash x is 0, f power 4 of x less than 0, then it has a local maximum at x naught. Means whenever second derivative 0, then only go for this story. otherwise we should not. 90% second derivative will not be 0, rarely it will be 0. In that particular case, then you can apply this. Similarly, if n is even, and f power n of x naught greater than 0. N is even number and nth derivative of f of x at x naught greater than 0. First even number is 2. If n is 2, f power 2 means f a double dash of x naught greater than 0. Then it has a local minimum. Then f of x has a local minimum at x naught. What is inflection point? Let us see now. So the previous two cases are n is even number. This case is n is odd. N is odd means n value 1, 3, 5, 7, 9, so on. N is odd and f power n of x naught not equal to 0. Look there, n is odd number and f power n of x naught not equal to 0. Look there, n is odd number, f power n of x not equal to 0. N is odd number means take n value 3, first odd number 1. First odd number 1, if I take n equal to 1, f dash of x naught, not 1. So if the stationary point we are talking about f double dash x is 0, after that this story arised, means n value will start from 3. If I take n equal to 3 here, then it is 3 minus 1, 2, means f double dash of x naught is 0. N value 3 here, f power 3 means f triple dash of x naught not equal to 0. The point at which f double dash of x naught 0 and f triple dash of x naught not equal to 0, that is called inflection point, which we have already discussed. So therefore, if n is odd number means n value 3, f triple dash of x naught not equal to 0. Next odd number 5, f power 5 of x naught not equal to 0. Then x naught, then f of x has, then x naught is an inflection point. Then x naught is an inflection point. Means what? At this point, graph of the function has neither a maximum nor a minimum. Point of no maxima, no minima, that is inflection point. So this is the story, brief review about local maxima, minima of single variable. We will stop the session. We will do problems in the next session. Thank you one and all.